Tonight we're looking at operations with radicals. Our first problem, 8 root 6 plus 3 root 6. At this point, we could simplify the information in the radical, but there's really no point to, because we notice that both of these radicals have the same value. And since they have the same value, we can add the coefficients together inside the radical and simplify that way. So we'll end up with 8 plus 3, which is 11, square root of 6. Since we already know from the previous 2 days that we're not going to be able to simplify square root of 6 because its factors would be square root of 3 times square root of 2, where nothing would simplify out of the radical, our final solution is simply 11 square root of 6. Problem number 4. Problem number 4 reads 2 square root of 3 plus the square root of 12. And now we notice that we have radicals with different values inside. The first thing I'm going to need to do is simplify the square root of 12 down into factors. Now remember, the first 2 days we focused primarily on what are the prime factors that go into 12. Now that we understand the process of factoring, we're starting to simplify that by looking more predominantly for what are the perfect squares first that divide evenly into whatever value we have in the radical. And if there's no perfect squares, then we'll simplify by identifying the prime factorization. Here I see the value 12 has a perfect square, square root of 4, times the square root of 3. The reason we're looking for perfect squares, it's very easy to simplify perfect squares. The perfect square, square root of 4, simplifies to 2, and that leaves us with it sitting next to the square root of 3. Now, so far, we've only simplified this information on the right side of the addition sign. So everything to the left side of the addition sign can now come down to square root of 3. And I'm going to bring the addition sign down. So we have the same value inside the radical sign, and I'm going to add the coefficients together. 2 plus 2 is 4 square root of 3. Now I want us to look at one that's going to end up with a slightly different answer than we're used to. Problem number 7. Problem number 7, the square root of 18 plus the square root of 108 plus the square root of 50. Now there's probably many different ways that you could solve this particular problem, but I'm going to show you the way that I noticed most easily. Square root of 18 can be divided by 9, and 9 is a perfect square. So I'm going to break that up into the square root of 9 times the square root of 2. The square root of 9 simplifies to 3 and leaves me with 3 square root of 2. So I'll bring down my addition sign, plus. Now I need to simplify the next term. Square root of 108. Well, the square root of 108 simplifies down to square root of 54 times the square root of 2. square root of 54 simplifies down to square root of 9 times the square root of 6, which is still going to be multiplied times the square root of 2. The square root of 9 is 3 times the square root of 6, which is the square root of 3 times the square root of 2. And I still need to bring down my square root of 2. Now remember today that we talked about the square root of 2 times the square root of 2. That's the same thing as saying 2 raised to the 1/2 times 2 raised to the 1/2. Since we have two like bases, we can add their powers together. So that would be like saying 2 to the 1/2 plus 1/2, which is 2 to the first power. So I tend to circle my pair and drop down the 2. Since 2 is now a whole number or a coefficient, I'm going to pair it up with my 3 and put my radical to the right of it. So that leaves me with 3 times 2, which is 6, square root of 3. Now you can see it's pretty important for you to keep your information clean and organized. This expression that we simplified earlier, I'm going to go ahead and bring down a little bit more so that it's parallel with what I have already. And now we can finally start cleaning up our third expression. So plus the square root of 50. Square root of 50 is obviously divisible by 25. So I'm going to have the square root of 25 times the square root of 2, where the square root of 25 will clean up nice and easy. That will give us 5 times the square root of 2. And that's as simple as that one gets, so we will bring it down even with the rest of our equation. Now at this point we can remember that the commutative property of addition tells us that we can rearrange a problem that's dealing with addition in any order that we want, and we will get the same answer. So 3 square root of 2 plus 5 square root of 2 plus 6 square root of 3. Now I notice that I have a 3 square root of 2 plus 5 square root of 2, which has the same value inside the radical. So I can add their coefficients. 3 plus 5 is 8 square roots of 2 plus 6 square roots of 3. And we end up with 8 square root of 2 plus 6 square root of 3 because there's nothing else that can be combined. That would be our simplified answer. Now I'm going to do one more problem for you. Let's look at problem 15 because it was rather fun. Problem 15, we have to remember our order of operations for problem 15. Order of operations tells us that we do parentheses first, exponents second. And I don't really have any exponents to deal with at this point, even though I could turn my radicals into fraction exponents, but that's not going to help us out. And then multiplication. We do have some multiplying of radicals that can be cleaned up in this problem. So problem 15 is negative 7 square root of 2 times 8 square root of 8 minus 12 cubed root of 343. Next, we're going to multiply our radicals. So first, remember we said inside, outside. I'm going to multiply the terms outside, those coefficients, negative 7 times 8, which gives me negative 56. Then I'm going to multiply the insides, which gives me 2 times 8 is the square root of 16. I like to go ahead and simplify whole sides of the expression. It may not always be the most practical because sometimes you'll find some things you can cancel out, or you will notice that you're trying to get to a certain value inside a radical, and simplifying it out too much at the beginning might keep you from getting those values or seeing those values right away. But since this one is square root of 16 and we already know that that's 4, I'm going to go ahead and do it. Negative 56 times 4 is negative 224. Now remember, we were subtracting, so I'm going to bring that operation sign all the way down. And then we have 12 times the cube root of 243. Sorry, 343. Now, 343 may not be the most obvious cubed root, and it may not even be the most obvious prime factorization. It may take doing a little mental math and figuring out what's the first prime number that goes into it. The first prime number that goes into 343 is 7. And once you divide it by 7, you're going to end up with 49 and realize right away that the cubed root of 343 is 7. Now we have 12 times 7, which gives us 84. And so our final step is negative 224 minus 84, which equals negative 308. Hopefully this has helped you to remember your processes for multiplying, adding, and subtracting radicals. Have a good evening.